in a moving coil galvanometer, there are two magnets, okay, north pole and south pole. So what happens? This is the magnetic field. Okay, this is the magnetic field. Okay, so this is the magnetic field, and now here this is the coil. Okay, this is the coil, and this SP is what? Spring. Okay, now here these two are the magnets. They are permanent magnets. Okay, they are permanent magnets. Permanent magnets. Now here this is a scale. Okay, so this is a scale here. This is a scale, and you know, these are the linings. Now here we have this is a coil, and there is a spring. Okay, there is a spring at the bottom, and on the top there is a there is, you know, on the top there is a pointer. Clear? This is a scale, and there is a pointer. Clear? This is pointer. Now, so this one is said to be what? Soft iron core. This is soft iron core, and this one is what? Uniform magnetic radial magnetic field. Uniform radial magnetic field. Uniform radial magnetic field. So what is the form? See, once again, there is a coil. Okay, there is a coil, and now there is a coil which is placed between the two poles of a magnet, north and south pole. They are permanent magnets, and this is a soft iron core, and there is a uniform magnetic field, and this one is what? A scale. Okay, this is a pointer here. Now, so we are here. That is tau is equal to what? The formula here is tau is equal to the when you, there are two torques applied here. One is when, see here, when the here when the current is flowing through the coil. Okay, it's like a coil like this. The coil is like this, and it is on the top there is a pointer, at the bottom there is a spring. Okay, now when the current is flowing through the coil, around it there is a magnetic field. The magnetic field here around it and the magnetic field of this, they get repelled. And due to which what happened? Magnets cannot move, they are fixed. The coil will rotate. When the coil is rotating, on the top the pointer will move. At the bottom there is a spring. Spring will try to bring back. If there is no spring, the pointer will go to the end. It will not come back. So there is a spring which is made up of phosphor and bronze wire. Okay, so it will try to bring back so that the pointer will not break. Only that is the intention behind keeping a spring at the bottom. Now, so here what is the torque? Tau is equal to what? Tau is equal to NIAB. Okay, tau is equal to NIAB. N is the number of what is that? N is here. N is number of turns. Okay, N is number of turns. I is the current. Okay, A is the area. Okay, area of the coil. A is the area of the coil, and B is magnetic field. Okay, A is area of the coil, B is magnetic field. Okay, now here there is one more torque. There are two torques. One is tau is equal to what? K phi. What is K? K is spring constant. Okay, or torsional constant, or we say spring constant. Tau is the this one is what applied for. This is restoring torque. Okay, this is restoring torque, and this one is what? Applied torque. This one is applied torque, and the second one is restoring torque. So K is what? Spring constant. Spring constant, and phi is what? Phi is deflection. How much deflection, or the angle, whatever it is. So we are taking applied torque is equal to restoring torque. Okay. So therefore we get what? K phi is equal to what? K phi is equal to NIAB. Okay. K phi is equal to NIAB. Now phi is equal to what? Phi is equal to NIA divided by K into B, because all these are constants. N is constant, or sorry, B is also constant here. Okay, A, B is constant, I is the current. Current is variable. N is number of turns, B is the magnetic field, A is the area of the coil, K is the spring constant, and phi is the deflection. So the deflection is directly proportional. In simple words, what is that? The deflection is directly proportional to the deflection implies deflection is directly proportional to the current I. Okay, deflection is directly proportional to the current. That is the thing. Now here we have to convert that is galvanometer to ammeter and galvanometer to voltmeter. This is also related to the practical also. Okay, what is a galvanometer actually? A device. What is galvanometer?
That measures the potential difference.
Potential difference.
So it's used to measure the deflection
Deflection.
or resistance.
Presence of current. Presence of current. Okay, clear? So galvanometer, see, we have, see, ammeter here. Ammeter is an instrument which is device which is used to measure the current. Okay. And milliammeter is what? It is used to, this is milliammeter. 549. That is 10 to the power of -3 amperes. Microamperes is 10 to the power of -6 amperes. And nanoampere is what? 10 to the power of -9 amperes. Okay. Nanoampere is 10 to the power of -9 amperes. Clear? Is that clear? So
Yes, sir.
Yes, sir.
milliampere, A is the current, milliampere is 10 to the power of -3 ampere. Mu A is microampere and Na is nanoampere. Clear? So this is what had happened. Okay.
Yes, sir.
Okay. And now so we have to measure. This is only to just detect the presence of, sometimes we say only to detect the presence of current, galvanometer. Nanoammeter or galvanometer is same. Okay. 10 to the power of -9. Nanoammeter or galvanometer. Is that clear? Any doubt in this one? Yeah.
No, sir.
We will discuss about how to convert galvanometer to ammeter and galvanometer to voltmeter. These two we will discuss and this chapter will be done. Okay. I will discuss all the Viva, don't worry. So maybe tomorrow. When do you want the Viva discussion? Just tell me. I'll take a separate class for that and we will discuss. Yeah, okay. So we'll discuss the Viva also. Okay. Now let's copy this fast, then we'll go ahead.
Yes, sir.
Yeah.
Yes, sir.
Okay. Now clear?
Yes, sir.
Okay. So I'm writing here for you. Next one. So I will just convert. Now we will convert galvanometer to ammeter and sensitivity also will discuss. This is the important one. Okay. The numerical is important here. So suppose conversion of galvanometer to ammeter. I'm converting a galvanometer to ammeter. Okay. So what is the procedure? See here. We connect generally a galvanometer is having a resistance. Okay. Galvanometer is having a resistance. Okay. So what is that resistance? Now. So here it is RS. This is RG. RG is the resistance of the galvanometer. And this is the dotted line. So here. So what happened? They are in when you connect a resistor in parallel, that is said to be shunt resistance. Okay. So what is the formula here? RS is equal to what? RS is equal to, they are in parallel, right? What is the formula for parallel? 1 by R is equal to what? 1 by R1 plus 1 by R2. Okay. So implies what? R is equal to what? R is equal to R1 into R2 divided by R1 plus R2. Clear? So here we have R is equal to what? RG into RS divided by RG plus RS. Okay, RG plus RS. So RG is the resistance of galvanometer. I'll write here. RG is resistance of galvanometer, and RS is what? Shunt resistance. RS is shunt resistance. Clear? So this is the formula. So here this is equivalent to what now? RG plus RS. The total value we are writing as here, which is equal to what? Equal to RS. Why? Because RG is much greater than RS. If you substitute the value, see, RG is in 1000, RS is maybe 100 or 50, something like that. When you substitute the value, this is much greater than this. So automatically it will become RS. Now, this is the formula for that. Next is what? Current sensitivity. What is the meaning of current sensitivity? Physical meaning. Anyone? What is the meaning of current sensitivity? Yes? Anyone?
Sir, is it the deflection per unit flow of current?
Current sensitivity, yeah, means how means for the given current, how much deflection is there? Got it? For given current, how much deflection is there? So maybe how much movement is there in the needle? That is said to be what? Current sensitivity. So we are writing here current sensitivity formula is pi by I is equal to what? That is NAB by K. NAB by K. That is said to be current sensitivity. Okay. So next one is what? Next one is galvanometer, converting galvanometer to voltmeter. Okay, converting galvanometer to voltmeter. Now what happened here? Here also the same. Now suppose this is the galvanometer, and this is the RG value, and this is RS value. Okay, so this whole thing is that galvanometer. This thing is what? Galvanometer, and this is RS. RS we are connecting in parallel, so that will convert into voltmeter. Now they are in series. What is the formula for series? R is equal to what? R1 plus R2. So similarly, we are writing here. What is that? Here R is equal to what? R is equal to what? RG. I'll write capital R here better. So RG plus R. So implies what? That is equal to what? RG plus R, which is also equivalent to R. Okay, that is equivalent to R. So we are connecting a high resistor, large resistance in parallel. Okay. Here we are connecting a small resistance in. This is high resistance connected in series. High resistance R is high resistance. High resistance R is connected in series. Okay. Connected in series. There is a formula. Now, voltage. Here we have voltage sensitivity. Voltage sensitivity. So that is what? Phi by V, which is equal to what? Phi by V is equal to what? NAB by K. NAB by K into what? I by V. So I by V, which is equal to what? Which is equal to NAB by K into what? Into 1 by R. This is the formula for that. Into 1 by R. So that is said to be the voltage sensitivity. Clear? Now, when we come to understood now, that is phi by V is equal to what? NAB by K into we are multiplying and dividing, dividing V on both the ends. So I by V will become R. So if the number of turns here, this is about the voltage sensitivity. Now, if number of turns are increased to 2n, example, doubled, then what happens? The voltage and current sensitivity phi by I will become what? See, what is phi by I? The formula is here. Formula is here. So current sensitivity, if it is 2n number of turns A, B, then what will happen? When the number of turns, so what will happen? Divided by K, which will be equal to 2 times of phi by A. Maybe doubled. Okay, current sensitivity also will get doubled. Okay, so we can write phi by I here. Phi by I gets doubled. Okay, then next one is what? If n tends to 2n, if n tends to 2n and R tends to 2R, okay, R tends to 2R, then what happens? Phi by V, voltage sensitivity, okay, phi by V is voltage sensitivity. So what will happen for that? Voltage sensitivity will remain same, Why it remains same? When this will increase, automatically what will happen? Phi by V. What is the phi by V? See, when current increases, proportionally what happens? When the number of turns increases, proportionally the voltage also increases. That is the reason it remains same. Okay. So this completes your lesson. So we'll do 1 or 2 numericals based on this. Then quickly we can move to the next one. What happened? I'll give 2 questions. Just take a picture and try to solve this. Okay. You just hold it.